Good morning. Today the subject we are going to study is mechanics of solid. And in this lecture I will cover following topics. This is my first lecture for this subject. The topics covered are: number 1 is normal stress, another one is shear stress, engineering stress, true stress, elastic region and plastic region. These are the topics which we will cover in this lecture. So the mechanics of solid, what is the meaning of this subject? Mechanics of solid is a subject which deals with the behavior of the material under application of different kind of forces. For example, there is a shaft or a cantilever beam like this. Let us say this is our beam, and normal force this is applied over here. After that, a bending moment is also applied over here. After that, a torque is also applied over here. This is torque T. This is bending force F, and this is force, normal force N, and a bending moment M is also applied over there. So there are so many kind of forces applied on this particular element. Now we want to know that how this element will behave under the application of all these kind of forces, and we want to find out what should be the diameter of this material, or what should be the cross-sectional area of this element when we want to design this element so that this element can sustain all such kind of forces. Okay, so we draw a stress element over this and we analyze this stress element. All these things are we will study later in our subject. Now, as this is the beginning of our subject, so to find out all these things we should have very strong basics. Otherwise we cannot calculate all these things under the application of different kind of forces, right? So for that, first of all, our basic should be clear. So first point we want to cover is normal stress. What is a normal stress? Normal stress is represented as sigma n, and normal stress is equal to normal load per unit cross-sectional area cross-sectional. This is known as normal stress. For example, there is a beam like this, a cantilever beam or cantilever rod or something like this, which has some cross section. Here I am considering it as a circular one, and a normal force, this Pn, is acting upon it, and this is the area. This is the area which is normal to this particular load. So normal stress will be equal to normal load by cross-sectional area, which is this one. Students normally make mistakes. They take any area like this area or any area across any axis. That is wrong. The area will be normal. So for this will be a normal load. This could be a component of this particular normal force component P theta, and over this cross sectional area, then normal stress on this elliptical section will be this one. You must be able to understand that if we cut this cross section on a cylindrical rod, if we cut it like this, then it will be ellipse and not a circle, and force normal will be like this. So this will be normal stress. One should be able to understand this fully, because otherwise in numericals there can be too much mistakes, right? Now this is the normal stress, and this normal stress is responsible for expansion of material within elastic limit. This line is very important, because whenever we applied normal loads over this normal loads, this thing must be understood. These are normal loads. I am considering this in 2D, 2 dimensions. One is x direction and one is y direction. So I am representing it as sigma x, and here I am representing it as sigma y. Now these particular two kind of stresses will be responsible for expansion expansion of this material, so its size will increase within elastic limit. This particular line is important, within elastic limit, so its volume will increase, so normal stress is responsible for expansion of material within elastic limit and its volume will increase, right? Normally students get confused that there are so many kind of stresses like bending stress, normal stress, torsion stress. All these are wrong concepts. There are mainly two kind of stresses. One is this normal stress, another one is shear stress. There are so many names in so many books to make the student confused. So student get confused and keep on just remembering their names. So no need to remember so many names. There are only two stresses. One is normal stress, another one is shear stress. So we know that this normal stress is responsible for expansion of material, that is volumetric expansion, and this shear stress which is represented by tau. So this is known as shear load. Here I represent P tau. Say shear load upon shear area shear, right? So this force is applied along the surface. For example, this is your element, machine element, and you apply force over this like this. This is P tau, and there is an opposite reaction in this direction. I am drawing the free body diagram of this element, right? So there will be like this and it will be like this. So every action has equal and opposite reaction. There is an action, there is a reaction. So what kind of shape this material will or this element will get after application of this force? How this solid material will behave under the application of different forces? So its shape may get distorted. It will become something like this. So you are able to understand that it will distort the shape. So this shear stress is responsible for distorting the shape, of the element. So now we are able to understand that mainly there are two types of stress. One is normal stress, which is denoted by sigma, and another one is tangential stress, which is responsible, or tangential or shear stress, which is responsible for deformation of the material or changing the shape of the material. Another one, students sometimes ask that, sir, whether we can see the stress with the help of a microscope. So it is not possible. Stress is a concept. It is a concept to understand the behavior of material under the action of different kind of force. Now there is another important question asked by students, that, sir, this is stress. Stress is equal to load by area of cross section. Load is represented in Newton like this. This is Newton, this is the unit, and area is represented in either meter square or millimeter square. So Newton per meter square is the unit of stress. Now if I ask pressure, the unit of pressure is also same, that is Newton per meter square. So pressure is also same. So what is the difference between pressure and stress? This is a normal question asked by many students. So the pressure is applied externally. This is external force. We apply pressure externally, right? And when we talk about stress, it is the internal resistance of material to the deformation. This is internal resistance of material to deformation, right? So this is the difference between stress and pressure. So one should understand it clearly, that what is the difference between stress and pressure. And moreover, in this diagram, if we see that, sir, there are so many kind of forces applied, like bending applied, we will call it bending stress, torsion is applied, then we will got torsion stress, moment is applied, normal load is applied. Moreover, this component shape could be something like anything, like it is moving like here, and after that it is coming like this, and after that it is coming like this, after the and force is applied over here like this, P, and one moment is also applied over there, one torque applied over there. now, and this element is fixed over here. Now we want to find out what should be the dimensions for this particular dimension. Actually, what we will do, we will draw the free body diagram, and after that we will find out this stress element in each of these, and find out the actual stresses induced in that particular component, in that particular line, and we will be able to find out the dimensions of that particular area, right? So these are the two concepts which I had cleared, like normal stress and shear stress. Another question is, what is engineering stress? Now I'll delete all this. You can pause and note down all the concepts. Let me clear this area, right? So what is engineering stress? Engineering stress is represented as sigma E. Either it is represented as sigma E, or it is represented as sigma O, that is original, right? Now what happens, that if there is a rod like this, okay, and you apply a load over this is the load applied over this, which is normal load, and this is P, and similar load is applied over there, this is normal load, which is Pn. Under the action of this normal load, what will happen? When we increase the load kg by kg on our universal tensile machine testing machine is one which is used for testing the samples, right? So what will happen, its length will increase. Its original length is say L, and its area of cross section is say A, and its diameter is say D, right? I am just drawing it. Its diameter is D and its area is A. Now engineering stress says that engineering stress is equal to normal load by original area. Original, O is for original area. But do you think that area will be original always? Because when its length will increase, this diameter will decrease, na? Its diameter will decrease. So this particular length will keep on increasing like this, and its diameter will decrease by del D. So it will be D minus del D, okay, like this, and this load is Pn, okay. So when its diameter will decrease, the area of cross section is equal to pi by 4 into D square. But now the diameter has been reduced, so area of this element will also reduce. So area is not same as it was at initial stage. In engineering stress, calculation of engineering stress, we always take original area which was there during initial stage. Now the original stress will be here, this is known as engineering stress, but actual stress is true stress. So what will be true stress? True stress will be equal to normal load per unit actual area A. Actual area is calculated by actual diameter. Now this diameter is changing at every second, so what will be this will be the true stress. Sorry, it is represented by sigma T. It is represented sigma T. This is true stress and this one is engineering stress. So you understand what is the difference between true stress and engineering stress. Now which one we should use? Now this true stress is the actual stress, but most of the design time we use this engineering stress for designing our machine elements. We don't use true stress, while the actual true stress is this one. This is the actual one, but this is not required. This one is required. This one is required because up to point of elasticity both the stresses are almost same. So to make it more simplified version, to make our calculation more simple, we use engineering stress rather true stress. Okay, so this is the difference. Next is this is true stress. So now engineering stress is almost area is constant. So engineering stress will not vary. But here, in case of true stress, this area is keep on decreasing. This is keep on decreasing because we will apply load, its length will increase, its diameter will decrease. So this area will keep on decreasing. So true stress will keep on increasing, right? So this is true stress. But when we are designing a machine element, we will go for engineering stress. But when we are going for manufacturing, we will go for this true stress region. So on stress strain diagram, when I will explain stress strain diagram, then I will show you two regions. First will be the machine designer region, another will be the production engineer region, where the machine elements will be drawn. Now this is the main difference between engineering stress and true stress. Next is the elastic region and plastic region. Let me clear the space so that everything is clear. You can note down all these concepts. Now the question is that what is this elastic region and what is plastic limit region. When we say that elastic region, in elastic region, the volume of the sample under observation increase. For example, this is a sample, okay, and we applied this load. This is normal load. I am not talking of shear, don't get confused over there. We are applying this norm. Its volume will increase within elastic limit. Its volume will keep on increasing. But up to what point? Up to the point of elastic limit. Up to the point of elastic limit. Once the deformation started, that is the concept I will teach you in material science, that what is dislocation forest and how work hardening and work softening concepts are there, and how planes slip over one another, and how the deformation starts, right? So when the load crosses that limit, that elastic limit of this application of load, then this expansion will not be there. Then volume will become constant. And the expansion of material will start. It will not be a volumetric expansion, but length will increase and diameter will decrease at the same time. So volume will not increase. This is known as the elastic region. You can note down that in elastic region, the volume of sample under observation increase under application of load and return to its original shape when load is released, right? If I load it within elastic limit, then it will come back to its original shape. All kind of machine design is done in this region. मशीन डिजाइन रीजन है. जितनी भी चीज़ें डिजाइन की जाती हैं, एक्चुअल में जब मैं मशीन डिजाइन पढ़ाऊंगा उस समय बताऊंगा कि फेल सेफ और सेफ फेल थ्योरी क्या होती हैं. क्योंकि मशीन डिजाइन के टाइम में आपको विद इन इलास्टिक लिमिट आप मशीन के कंपोनेंट्स डिजाइन करते हो, राइट. दूसरी चीज रीजन आता है प्लास्टिक रीजन, कि भाई प्लास्टिक रीजन कौन सा होता है. प्लास्टिक रीजन वो रीजन होता है जब ये फोर्स इस लिमिट को क्रॉस कर जाती है. आपने you must have seen that in plastic region there is permanent deformation of material. For example, you must have seen many kind of materials, utensils at your home, where sheet metal like this, after construction or manufacturing, it become like this. So this is permanent deformation of this material. So in production, we are in this, what we call plastic region of the material, right? So in plastic region, there is permanent deformation of material. So you can note down, when there is no increase in volume of the sample, there is no volumetric expansion under application of load, but there is elongation or deformation of material in particular shape, then we call that we are in plastic region. Normally production activities, whatever production region is there, that is in plastic region, like deformation, for forming of material, all these things comes in plastic region. So I hope that all the basic concepts, as this is the first lecture of the subject mechanics of solid, all the concepts are clear. In next lecture we can study what will be the stress strain diagram for mild steel, what it will be for aluminium, what it will be for cork, what it will be for cast iron, how carbon percentage effect, all these things. And later on advanced concepts, we will study principal stresses, and after that we will go for beams, where we will study that there are so many kind of loads applied, and we want to know what will be its bending moment diagram, what will be its shear force diagram, what will be its say deflection, what will be its theta, and all these things will be studied. And only not only under the application of one force, there can be many forces applied on that beam. So similarly we will again study all these concepts in detail. But to reach at advanced level, our basics should be clear, otherwise our calculations will give us wrong results. So hopeful this lecture will be good for you and you will definitely appreciate it.